Okay, so welcome everyone to tonight's webinar presentation. My name is Erin Burkett, and I am the Lake Superior Outreach Specialist with the UW-Madison Division of Extension. I'm based up in Madison. Gonna give you a quick overview to the Zoom platform that we're using today. So even if you're already familiar with Zoom, or if this is your first Zoom, I want to point out a few features. So first, we're going to ask that while Zach is presenting, that you keep your video and audio off throughout the presentation. And you can, but at any time you can start adding questions to the chat feature. And then also later you'll have an opportunity to unmute yourself to ask questions and we can have a group discussion. I pointed out on this slide here where you can find the mute button and how to stop your video. That just helps a little bit with the internet bandwidth while we're sharing slides. The chat is pretty easy to find. It has a little pop-out talk box. And I also wanted to point out that we have enabled the live transcription feature. So you can adjust that if you don't need that or don't want that. You can hide it by clicking on the live transcript CC closed caption button and then hiding the subtitle, or you can also go to subtitle settings if you want to make them larger or smaller. So really quickly, this meeting is being hosted by the Lake Superior Collaborative. This is a watershed partnership focused on Wisconsin's portion of the Lake Superior Basin, as shown in the map up on the right. So this is a group that is dedicated to networking, knowledge sharing, and collaborative projects that enhance watershed resilience. If you want to learn more about this group, please get in touch with me. Here's my email address, or please visit our shiny new website, lakesuperiorcollaborative.org. And we also have a newsletter you can sign up for to learn more about events that we host and other news about Lake Superior. And I'll point out too that on our website, we have a new project story map, which is really fun and informative to click through and learn more about all the great work that's going on in the area. So without further ado, I'm going to introduce tonight's speaker, Zach Stewart. And there you are. So first of all, today's webinar is titled Stop Spiny, the Science of Invasive Spiny Waterfleas. Our speaker is Zach Stewart, who is the Natural Resources Specialist and Aquatic Invasive Species Coordinator with the Douglas County Land and Water Conservation Program. So Zach will present for about 30 to 40 minutes, and then we'll have plenty of time for questions at the end. But like I said before, if you have questions that come to you, feel free to add those to the chat as we go. And after Zach's presentation, I will moderate a Q&A. Your slides look great, Zach.
Good deal. Awesome. Well, hey, thank you for that introduction, Erin. I really appreciate that, and appreciate the opportunity to be here speaking to the collaborative tonight as well. So as Erin said, I'm Zach Stewart, and we are here tonight to talk about invasive spiny water fleas and the Stop Spiny prevention campaign, which seeks to halt or slow their spread in our part of the world in northern Wisconsin along the shores of Lake Superior here. So here's a quick outline of what I'd like to talk about tonight. We'll spend some time making an introduction to spiny water fleas. We'll talk a bit about their biology and their life cycle. I want to touch on the effect that they can have on lakes and fisheries when they get into a new lake. We'll talk about where they came from and how they spread, how to stop them. And then I'll conclude by just explaining the Stop Spiny prevention campaign and giving you a few options for how you can get involved if you're interested. So here's the star of our show. This is Bythotrephes longimanus, or Bythotrephes cedarstromi, as some folks are starting to adopt more commonly. It is the spiny water flea. This is a zooplankton, which means that it's an animal. So something this tiny we often don't think of as as an animal, but this is a small aquatic animal, and it's identified by this long, pronounced tail spine that you can see right here. It's 3, 4, or 5 times the length of the rest of the body. This little animal is a predator that can really change the plankton community when it gets into a new lake. And it's got some pretty neat abilities. It can reproduce quite rapidly through asexual reproduction or sexual reproduction, depending on the prevalent circumstances in the lake at that time. We're going to touch on that in a little bit more detail later in the talk tonight, because it's actually a really adaptive and interesting ability that this animal has. They can't be eradicated easily once they get into a lake. We have no approved, known, effective control methods for this invasive species right now. So the only strategy we have is to prevent their spread, or stop Spiny, as the name of the outreach campaign indicates. Luckily, there is some good news. They have a weakness. They can't really travel over land independently, and they dry out really quite quickly, and they die when they dry out. So there are some things that we can do to prevent their spread effectively. So if they're invasive here in northern Wisconsin, you might ask, where do they belong? Where did they come from? Well, they're native to northern Europe, and they arrived here in the Great Lakes very likely through the transport of ballast water in transatlantic shipping vessels, which then come up the St. Lawrence Seaway and exchange their ballast water here in the Great Lakes. So they were first documented in Lake Ontario in 1982, and they subsequently spread throughout the rest of the Great Lakes, including Lake Superior, and to some of our inland waters as well. Here in Wisconsin, they are an NR40 prohibited aquatic invasive species, which means that they're likely to survive and spread, potentially causing significant environmental or economic harm or harm to human health. And we'll touch on those factors a little bit later on. And there's a few different vectors that spiny water fleas can be spread through. One is water, just like the ballast water I talked about. Similarly, we have small little microcosms of ballast water in recreational boats, like our bilge water or potentially live well water. So that's something to really watch out for. If you check out this picture on the right side, that's a whole clump of spiny water fleas that are actually snagged up on a fishing line. And there's some really interesting recent research from Don Brandstratter at UMD in Duluth. And him and his group are documenting that fishing lines being trolled behind boats are actually quite effective at snagging up these spiny water fleas. And then, of course, if that fishing equipment is taken to a new lake and cast out there, it could potentially introduce this species into that new lake, which is exactly what we're here tonight to avoid. Mud is another vector. These spiny water fleas produce eggs in the fall, and the eggs lay in the mud. So anytime that mud gets moved from one lake to another, it's a potential risk for spreading spiny water fleas. So the good news is we can avoid all of these vectors for transport through our basic knowledge of clean, drain, dry your equipment before you move to another lake. And I know that a lot of people across Wisconsin who are anglers or boaters are familiar with that. And that's the same core message that we're putting out there through a lot of statewide aquatic invasive species initiatives, like the Drain Campaign, Clean Boats, Clean Waters, and some others. So it's not rocket science to prevent the spread of this harmful species. But they're also really interesting scientifically. So let's dive a little deeper into what spiny water fleas are and why we're so concerned with preventing their spread. So one reason is they can have negative effects on the lake ecosystem and the fishery. The way they do that is they reduce the biomass of our native zooplankton, which are important to lake ecology, and they tend to reduce biodiversity and disrupt the food web in a lake that they invade. In fact, there's some research out of northern Minnesota by Gretchen Hansen and her group that shows that walleye in particular are smaller and less abundant in lakes that have been invaded by spiny waterfleas. Why is that? We'll get into that in a little more detail momentarily, but in short, some fishes, especially the young of the year walleye or the the less than 1 year old walleye, eat a lot of zooplankton during their first year of life. We think of walleye as maybe eating other fish primarily, but when they're very young, they eat a lot of plankton. And their feeding and their caloric intake during that first year of life is critical to determining their growth throughout their lifespan. So if spiny waterfleas deplete and alter this stock of native zooplankton that these walleye are depending on, it has a negative effect on their growth. So let's take a little bit closer look at that research from northern Minnesota. This is a pretty in-depth study. There are 9 different lakes in northern Minnesota that were studied. And these are major lakes. Altogether, they represent about 1/3 of the annual walleye harvest in the state of Minnesota, which is, relatively comparable to the walleye harvest here in Wisconsin. And what they did is they went out and they used seine nets to capture these age 0 or young of the year walleye, and they measured them in lakes with and without spiny waterflea invasions. And they actually measured over 50,000 walleyes. So this is a pretty robust sample size. Now, before I show you the data from this research, let's just get ourselves accustomed to this little graph right here. So on the y-axis, we've got size of walleye in length. And on the x-axis, we've got time passing. And you'll see quite a bit in the talk tonight that we measure time in degree days, which is defined as just the number of days where the average temperature is above 5 degrees Celsius. So really, that's just time passing. And as we all know, not many things grow real fast up here during the cold winter. So we only count those degree days above a certain temperature. And then this orange arrow represents, what we're going to expect to see in walleye growth over time, right? A walleye is born and then it feeds, it grows, and the more warm, productive degree days that it lives through, the bigger it can grow. So now here's the actual data from the study. So up here on the top, again, we've got walleye size getting longer towards the top in millimeters, and then we got degree days going across the y-axis here. And the black line is for what I'll call normal lakes, or lakes that don't have an invasion of spiny waterfleas. So as you can see, those walleyes are growing bigger every degree day they live through. Now, if you direct your attention to the orange dotted line right here, you can see it's just got a significantly lower slope. So that slope represents lakes that have been invaded by Bithotrephes or spiny waterflea. So in those invaded lakes, we're seeing slower growth of walleyes over time. Then down here, this is in section B, this is kind of another way of looking at the same concept. The black dotted line here would be a normal lake or an uninvaded lake. And this graph shows the length difference from an uninvaded lake versus an invaded lake. So in an uninvaded lake, we're expecting to see 0 difference. That walleye is just going to grow at its average rate. However, in a lake that's been invaded by spiny waterfleas, on the orange dotted line here, you can see the slope is actually negative. So the longer that walleye lives in that lake, the farther behind it's falling on its growth. And we're seeing, after 500 degree days, we're seeing a 5 millimeter length difference towards the smaller side. And then that change compounds over time and walleyes who are trying to feed in a Bythotrephes invaded lake are falling farther and farther behind on that growth curve. Gretchen Hansen also looked at lakes with zebra mussels and lakes with both, which is the purple and the blue lines here. For tonight's purposes, that's not our focus, although it's really an interesting paper to read if anyone's interested in that topic. So there's quite a strong statistical relationship between the walleye growth and the presence of spiny water fleas. And the take-home message is that, on the average, walleye are likely to be smaller in lakes that are invaded by spiny water fleas. Now, I want to point out that although this is a really robust study, these impacts are variable through time and space. So fisheries biology is a complex system, and not every lake is going to behave the same every year. So is it possible to find big walleyes in spiny water flea infested lakes? Absolutely. But on the average, across this very large study size with 50,000 walleyes measured, there's a strong relationship showing that their growth is falling behind in those invaded lakes. There's also some interesting questions still outstanding regarding how different fish species might respond. It's pretty well established that walleye and yellow perch, which are both, exciting and economically important species, suffer and grow less quickly in lakes that are invaded by spinies. But cisco or whitefish and panfish may not necessarily have the same effect. They may be anecdotally more effective at being able to use spiny water fleas as food in some circumstances. I think that's a really interesting question, but it warrants a little bit more research to fully understand it. Shifting gears away from the fishery, spinies can also have an effect on the water clarity in our lakes. So they tend to reduce water quality when they infest a new lake. And they do that because they reduce the biomass of native zooplankton and alter the food web. So, of course, when you think about a lake ecosystem, the base of that ecosystem are our phytoplankton, which could be compared to plants in that they are green and they harness the power of the sun for energy. So those phytoplankton are going to bloom kind of, analogous to the way grass grows on the prairie. And then we've got a whole community of native zooplankton, which could be compared to the bison that feed on that grass. So they're actually grazers and they're eating the phytoplankton in our lakes, and they're keeping that food web roughly in balance, which is important for water quality as well as the ecology of the food web. Now, when spiny water fleas get in there, they disrupt that balance, reduce the biomass of our native zooplankton, and that can sometimes lead to over blooming of phytoplankton, which leads to this green water and reduced clarity. Lake Mendota, which many folks are familiar with down near Madison, Wisconsin, lost about 1 meter of visibility when it was invaded by spiny water fleas. So far, we're seeing, luckily, a somewhat smaller visibility impact on northern Wisconsin lakes. Another area for future research, but perhaps just due to the fact that our lakes tend to be much colder and much lower in nutrients than in the southern part of the state to begin with. And it could also be perhaps linked to predation by cisco or other northern species. I promised to touch on the reproductive capabilities of this unique animal, and it's really quite an interesting thing that they can do. So they can perform parthenogenesis, which is asexual reproduction, or gametogenesis, which is sexual reproduction, depending on the environmental conditions that they're experiencing. So when conditions are good and earlier in the season, a single female can produce 10 young every 2 weeks without mating. without even having to find a mate in that lake. So there's some obvious, concerning implications of that fact, given that we're trying to prevent the spread of this species to new lakes. Then, if conditions change and or when the fall rolls around, the spiny water fleas tend to switch modes, and they start going through that gametogenesis and doing sexual reproduction, which is important because asexual reproduction produces no genetic variability, right? So you're getting more and more clones of the mother spiny water flea, and you're not getting that diversity of genetic material and opportunity to adapt to a new environment that comes with that exchange of genetic material. So in the fall, they switch modes, they mate, they produce these resting eggs, which sink down through the water column and they land in the sediment. And those resting eggs are very durable, and they sit down there in the sediment until the following spring, or sometimes for multiple years until conditions are good, at which point they hatch and launch a new generation of spiny water fleas. So, the clump of mud pictured on the right here on this boat anchor could potentially contain a lot of spiny water flea eggs. And this is why you'll hear a lot of us AIS prevention types kind of harping on cleaning water, but also cleaning mud or sediment off of equipment before we move it to a new lake. There does tend to be relatively high mortality during the process of hatching those eggs and growing to an adult spiny water flea. So not every egg is going to result in, a fully formed adult spiny water flea, but there can be a lot of eggs produced. So it's still quite a risk. Generally speaking, it's understood that relatively high propagule pressure, or in other words, a large number of eggs arriving at a new lake, is needed to actually establish a full population. And that brings me to an interesting concept to keep in mind, which is that one propagule or one egg or one adult spiny water flea arriving at a new lake does not necessarily an established population make. So, we want to prevent ever having a single spiny water flea travel to a new lake. But if we fail and it does travel to a new lake, it does not necessarily guarantee that there's going to be a full population launched there. In part because some waters are more suitable than others. So this image on the right here is of my area where we run the Douglas County AIS program over here in northwestern Wisconsin. And it's from a tool called the AIS Smart Prevention Tool out of Jake Zandervanden's lab down at UW-Madison. And what this does is it takes some existing environmental data about numerous lakes and streams across the state, and it plugs them into a simple model, and it spits out, this salmon color for suitable or purple color for unsuitable. Now, spiny water fleas like cold, deep waters, and they live out in the middle of the water column. They're pelagic, so they're not necessarily making their home in the warm, sunny shallows. So for that reason, this model uses 3 variables to try to predict which lakes are going to be most suitable for spinies. And those 3 variables are temperature, measured as the number of degree days per year over 20 degrees Celsius, the surface water temp in October, and the depth of the lake. So these are pretty basic environmental data, and this model is not a guarantee. It's definitely not the be all and end all of whether your lake is going to get spiny water fleas or not. But I think it can be a useful way to look at risk and just think, in Douglas County here, for example, we have quite a number of suitable lakes in the central and southern part of our county. And so those are good areas to potentially focus our prevention efforts and make sure that we're not giving spiny water fleas a chance to get started in there. Tonight we're based over in Ashland with Aaron and the the Lake Superior Collaborative. So here's a map from that same prevention tool showing a broader area of Lake Superior's South Shore. And as you can see, there's quite a cluster of suitable lakes right here. This is Bad River Slough, I think. That definitely looks like a modeled suitable water body. And then there's some real tiny ones west of Washburn here. And, you know, I would keep an eye on all water bodies regardless of modeled suitability, because like I said, this is not a guarantee that, you know, any given lake is going to be safe from spiny waterfleas. So to dive a little deeper into that dynamics of invasion and that likelihood of invasion, let's talk about the paleolimnological approach, or the lake sediment approach. There's a really nice thesis from UMD by Nicole DeWeese a couple of years ago, and she looked at spiny waterflea microfossils in the sediment from several lakes. These are different microfossils that get left behind by spiny waterfleas. These things fall in the sediment and they get covered up by silt and mud. And she took a series of sedimentary cores, used lead-210 dating to establish how old they were, and then sifted through these things really painstakingly and used a microscope to pull out and identify these different fossils that indicate the presence of spiny waterfleas. And her findings are quite interesting. She found probable evidence that some of these spiny waterflea fossils were present in sediments that are older, much older in some cases, than their detection in the water column. Older by about 100 years, actually, specifically in Lake Cabotogama and Mille Lacs Lake. So what does this mean? Well, the suggestion of these findings is basically that there can be a big lag phase between when the spiny waterfleas first arrive, their invasion, and then their subsequent detection, the first time that you know, an AIS person monitors them and finds them in a plankton net, or the first time an angler finds one stuck to a fishing line and reports it. So that's quite interesting to me, because it suggests that spiny waterfleas can potentially arrive in a lake and survive in low numbers undetected for years or tens of years or even 100 years in some of these instances. And then all of a sudden, their abundance can just explode from that sort of latent smaller population. And some suggestion that that explosion, that end of the lag phase, can be triggered by environmental effects such as an unseasonably cool summer. Specifically, Lake Mendota down near Madison, they think that the end of the lag phase and the explosion in population and then the subsequent detection of spiny waterfleas was triggered by a particularly cold July that just gave these animals the exact conditions they wanted to reproduce like crazy and take off. So it's interesting to consider that there could be undetected latent populations of spiny waterfleas in some lakes in our area. For example, folks who are familiar with Whitefish Lake, there actually was a detection of spiny waterfleas there back in 2006. And then they haven't been detected again since 2006. Are they still out there? We hope not, but we're not certain. So I'm actually looking for some resources right now to get out and do some more detailed sampling and see if we can verify whether or not that population is still surviving. I think it's really important to monitor for this species and really look closely so that we can know where we stand. How many inland lakes have these spiny waterfleas actually successfully invaded so far? Oh yeah, and I love this quote. So from the thesis paper I was just referencing, it is likely that Bithotrephes has invaded other lakes and evaded detection, kind of getting at what I was just talking about. So I'll be doing some sediment sampling with our Douglas County Water Resources and AIS program soon, and encourage folks to get in touch if they're interested in those results or want to participate in their area. So let's pause here for just a sec. Now we know some things about spiny water fleas. We know what they are and where they came from. And we have talked about how they can be prevented, and we've talked about why we want to prevent them and what sort of effects they have when they get into a lake. And I just want to kind of summarize and help you remember why it is that spiny water fleas might have these effects. So to explain that, up first, I want to introduce you to one of our native zooplankton species. This here is a Daphnia species. This is kind of analogous to the grazing bison on the prairie that I was talking about earlier. So this is our native species that should be out there just eating phytoplankton and organic matter, swimming around, and providing, importantly, a good source of food for walleyes. And I'm a bit of a visual learner, so I imagine that in the eyes of a hungry young walleye, this Daphnia would look something more like this. It would be a juicy meal, pretty appetizing, and it's got, you know, this little tail spine here that probably can be dealt with. Now compare that to our invasive spiny water flea, which looks like this. It's got that huge tail that it's named after. And if I let my imagination run wild, I think that this is a little bit more intimidating. It's kind of it's a bigger creature. It's got these big spines. We know that it's a predator, and it's out there eating those juicy Daphnia and decreasing their population, taking the food away from the young and deer walleyes. And then on the other side of the coin, it's also not a very good food source for fish because of those big sharp spines. So when a tiny little walleye looks at eating one of these big spiny guys, I imagine it looks something more like this. It's of questionable nutritional value, right? It's pretty pokey, it's pretty hard to deal with, and we actually do see evidence of this. A lot of fish have difficulty even eating spiny water fleas because they're so big and spiny. And those that do can actually, in some instances, be injured by eating them. So those spines can cause a pretty bad stomach ache. Let's say they can even actually pierce the wall of the stomach of fish sometimes and cause severe injuries. So these are not the best prey item for our walleyes. And keep those images in mind next time you get a hot dog or a hamburger. So with that in mind, I want to just conclude tonight by touching a little bit on the Stop Spiny campaign that we're here tonight to talk about. So this is a multi-county prevention and education campaign that I started a couple of years ago. And the goal is to prevent the secondary spread of spiny water fleas. Right now, this is our project area outlined in orange. I'm hoping to expand that at some point, but for now, we're focusing on the 4 northern Wisconsin counties that border on Lake Superior. And we have a few documented infestations here. One right here at the St. Louis River estuary near Duluth and Superior. Lake Superior itself has spiny water fleas, so that's a potential vector all along the shore of Lake Superior. And then the Guile flowage over here in Iron County is quite popular for fishing, and that's got a big population of spiny water fleas. So we want to prevent the secondary spread from any of those known locations into our hundreds of pristine water bodies in our area. So to do that, there's 4 key activities in the program. The first is, interesting educational presentations like tonight. They're quite adaptable as far as the time frame and the level of detail. So I just want to throw it out there to folks listening tonight. If you are a a professional or a member of a lake association or a sportsman's club or anything like that, if you think your group would be interested in learning more, I'll put my email up at the end, and you can please feel welcome to reach out to me. And I'd be happy to come and speak with your group as well. Second, there's a multimedia campaign that I've been organizing for a while now. There's some print flyers available, videos. I think Erin is going to be posting a recording of this talk tonight online, actually. And I also have digital materials that can go on web pages for lake organizations or social media accounts. Watch out this May as you're driving around for a radio ad too. I'm excited. We're gonna have a little Stop Spiny message playing on Wisconsin Public Radio during fishing opener. So you can listen for that. Number 3, we've got these great cleaning cloths. These are a Swedish dish towel material, so they're real kind of tacky. And if you think back to earlier in the talk, Don Brandstratter and his group had shown that fishing lines are an important vector that can snag up these spiny water fleas. And these Stop the Spread spiny water flea cleaning cloths are a really great tool for cleaning spiny water fleas off your fishing line before you travel to a new lake. And I've got a bunch of these, they're free. So get in touch if you want some to help remind people in your area to clean their equipment. And then number 4, I do a little training for our clean boats, clean water inspectors so that they can be well informed and help watch out for spiny water fleas as well. So in conclusion, if you take one thing home with you from tonight, it's remember to clean, drain, and dry your own equipment when you're out there on the water. Try and share some of what you learned in the Stop Spiny message with anyone who will listen to you. And reach out to me if you want to get involved. I really welcome that. I'm hoping that we can all work together. And if we take these simple actions, we can keep our lakes healthy and keep them stocked full of these juicy native Daphnia instead of these gnarly spiny water fleas. That's the end for tonight. Thank you all so much for listening. Really appreciate your time. Here is my contact information. Feel welcome to use that, reach out. And I just want to really quickly thank all of the partners listed at the bottom here, as well as the Lake Superior Collaborative. None of this work would be possible without their support, so we really appreciate it.
Thank you so much, Zach. A few questions in the chat, so I'm going to go scroll up to the first one, which Allie asked. This is going back to when you first started talking about the degree day standard in the walleye study. So the question is, do you know if the degree day standard of 5 degrees Celsius is specific to spiny water flea or the freshwater lake system? Noting that that standard can change depending on the organism. So just kind of wondering more about where that 5 degrees came from.
Yeah, a great question. I mean, I guess you'd have to really ask Hansen and her group who did the study, but my understanding of that is that it's somewhat arbitrary. What it's really doing is it's just creating a measure of how many warm growing days has this walleye lived through. So I think my intuition is if you were to rework all of Hansen's numbers using, a standard of how many days above 0 Celsius or how many days above 10 Celsius, I think that you would very, very likely find the same results.
Thank you. And then a question from Cindy, how are spiny water fleas dangerous to humans?
Thanks, Cindy. Yeah, they're not that I know of. That's a great thing you touched on. I'm glad you brought it up because in the definition of an NR40 prohibited invasive species in Wisconsin, it measures harm, harm to the ecosystem, economic harm, and potential harm to human health. And some invasives do have harmful impacts on human health, like they're slightly toxic or they can release harmful chemicals into the water. As far as I'm aware, spiny water flea is causing economic harm, harm to the fishery, harm to the ecosystem, but they're not a threat or a danger to humans. Aside from, I guess, the fact that they do disrupt the food web in a lake, leading to a possible overpopulation of phytoplankton, which conceivably could mess with the nutrient dynamics and encourage harmful algal blooms. But I would say, really, if you've got a harmful algal bloom in a lake, that's really the cyanobacteria that's blooming in that lake that's causing that harm more directly than the spiny. So, and they're too small to bite people, which is really good.
So then 2 more questions that are kind of related. First is, do they have any natural predators? And then another one that's related was, do bluegills eat spiny water fleas, or is that a myth?
Yeah, awesome questions. They've got natural predators, especially in their home range in Northern Europe. And, part of what makes them invasive here is that they do not have a ton of natural predators here. All sorts of fish can eat spiny water fleas, and they do it. There have been some studies that show that they're not the preferred food. Like if you put a walleye in a tank and then you float the juicy Daphnia and the spiny water flea down, they tend to go for the Daphnia for pretty obvious reasons. That being said, fish can still eat them, and they do, and the fish don't always get harmed or die. But the spiny water fleas are probably not providing as good of nutritional value, as good of a quality food item for that fish as they could be. And then to the second part of that question, do panfish eat spiny water fleas, or is it a myth? The answer to that question is kind of yes. So I think I just want to acknowledge that there's a lot that is not fully known or fully proven about that relationship yet. So I think we need to have some humility and just acknowledge that we have more to study and more to learn. That being said, I am aware of some diet work where fisheries biologists from our region have basically cut open the stomachs of panfish, and they've found spiny water fleas in there. And these are live captured panfish, or panfish that were thriving perhaps until they were netted for routine fisheries studies. But that is suggesting that some panfish, especially pumpkin seeds, can successfully eat spiny water fleas without being killed by them. Now, that does not mean that panfish love spiny water fleas, and it does not mean that panfish are going to be the answer to being able to control spiny water fleas once they're in there. I think both of those questions are really interesting, but I think that we need some more data to look into those questions further.
Thank you. And then a couple questions about prevention, or detection, I should say. So first is, how can we check our own lake for spiny water fleas? What's a good method to catch them?
Yeah, great question. So the most commonly used method is a plankton net tow. And basically, that's a big cloth, it's a big cloth net that's kind of cone shaped, and they're usually like 1 meter or 2 meters long, and they're 50 centimeters to 1 meter wide, and they're held open with like a hoop, and you just pull that behind a boat. There's 2 different ways to do it: vertical or horizontal. For quantitative studies, some folks prefer a vertical net tow for spiny water fleas, but it depends on what you're trying to do. I think for a lot of us, we don't necessarily need a ton of detail in our spiny water flea monitoring. We're just trying to answer one question: are they here or not? And if they are here, we may choose to go beyond that and do more detailed sampling. So that's one option. Plankton nets are like a little bit expensive, in the $50 to $300 range. If you're in my area though, reach out to me and we can talk about getting lakes sampled. I think Scott Caven is our wonderful AIS coordinator in the Ashland area there. So he's an awesome contact as well. And pretty much most counties around here have a local AIS coordinator who could help with that. And then sediment sampling is the other big method. We talked about paleolimnology. So getting an Ekman dredge or a scoop of sediment from the deepest hole and then sending that off to the state lab to be analyzed for microfossils is another way to look. I'm going to be hopefully doing some of that soon, but that's got a cost associated with it as well. So great thing to do. A plankton net tow is probably the best DIY method if you want to just check your own lake.
Related question, and I know you showed I think early on one of those images with the clump of spiny water fleas on the fishing line. So is that a potential way to sample or collect? Like, can you dangle a line and they clump up, or how common is that to see that clump? Does that mean there's a really hefty population?
Yeah, that's an awesome idea. That is absolutely a great do-it-yourself sampling method. Basically, go fishing, troll a line for a couple hours behind a boat, and then be very observant as you reel that line back in and see if you're getting. What happens is, the spinies are like half an inch to 3/4 of an inch long. They're floating in the water column, and if you pull like a weight through the water, that weight is going to displace the water and cause the spinies to wash around the side of it. But when you pull a fishing line through the water, it's like a little knife just cutting through the water, so it doesn't push much water and it hits the spinies, catches on those tail spines. And when you go through a thick population, you can actually end up with quite a clump of them on there. This happens in Lake Superior near the Twin Ports in Duluth, certain seasons, especially like August, September, when the populations are really blooming. And you can get quite a nasty big clump of them on there. So that's a really great way to sample. I would just caution that, like with any of these methods, if you go pull a fishing line through your lake for a few hours in August or September and you find a bunch of spiny water fleas on it, that tells you you've got spiny water fleas for sure. If you do the same thing and you find no spiny water fleas, it's inconclusive, right? Because it could be that you just missed them. You went out the wrong week or the wrong part of the lake. Still worth doing, I think.
Okay. And then about the prevention of spread, how long should a boat or live wells or other fishing equipment or gear dry to make sure that they are dead? Like how long would that take?
Awesome question. There is some evidence that shows spiny water fleas and the resting eggs cannot survive more than 6 hours of being dried out. But that's 6 hours of being fully dried out. So here's what I worry about. If you're reeling in your line and a few spiny water fleas get pulled in with it, and then you reel a bunch of wet fishing line over top of them, and then you throw that in the bottom of their boat, you let that dry out for 6 hours. Well, is it really drying out inside that reel of line or inside that live well? Not really. So they could be surviving then. Now, if everything is like baking in the sun and it's getting nice and dry, then yes, those spiny water fleas are going to be destroyed in about 6 hours or so. Not so much if it's a rainy day though. So that's something to think about as well. And that's where our cleaning cloths come in, because I know it can be exciting if the bite is on, you want to get from one lake to the next. I personally love to fish. So what I do if I'm moving straight from one lake to another is I just get out the Stop Spiny cloth, and if you put some elbow grease into it, 5 or 10 minutes, you can have a boat like really nicely dried out. All the water's gone. you strip off your fishing line and visually check for any spinies, and then you can head on to the next lake feeling confident that you're not bringing anything with you.
Thanks. So we have Zach is here until 7, so keep putting questions in the chat. I want to go back to something you said about you mentioned that fish can be damaged when they eat them, or maybe it was their stomach or digestive tract. So is that more common for young fish fry? Is that like, could that be lethal for them, or is it more like damaging and could affect them more over time?
It can certainly be lethal. Anecdotally, I've heard from some fisheries folks that they have cut open young fish and the stomach actually looks like a pin cushion, with dozens of spiny waterflea spines protruding out of it. Not to be too gruesome, but I think where that can lead to mortality potentially is when that mass of hard tail spines is penetrating the stomach and the digestive tract, and it's just building up in there like a blockage, so that fish can no longer feed effectively. Now that doesn't happen to every fish that encounters a spiny water flea. I think that's kind of the most extreme case. So it's not like every walleye gets damaged or killed when it eats a spiny water flea. And I do think that larger individuals are going to have a little bit better capacity to deal with successfully passing those big rough food items. But yeah, can be really harmful if they eat them in a large quantity.
All right, looks like a couple more. So what was the law NR
40.
NR 40 that you mentioned? So this is kind of a legal question here. If a boater has, oops, my screen just moved here. If a boater has come from a lake with spinies, could someone legally keep them out of another lake and maybe report them or something?
Yeah. I mean, I think I have to charge a lot more if I'm going to give legal advice. No, but jokes aside, yes, I mean, NR 40 is Wisconsin statute, and it is not legal to possess or transport harmful invasive species. Generally speaking, the way that this is handled best is through outreach and education more so than enforcement. But that being said, we do, like a lot of folks, staff clean boats, clean waters inspectors at the launches to do just this, look for invasive species. And the way that goes is they're called inspectors, but they're really there to educate and have conversations with people, more so than, pull out their badge and inspect and enforce. But that being said, it is not illegal to move a prohibited NR 40 prohibited species, or possess it. So if it really came down to it, and someone was encountering that at a launch, it would be appropriate to contact the local game warden or conservation officer and ask them to do enforcement in that situation. I think the person asking the question, I'm sure, knows this already, but I encourage folks to use the friendly and educational approach. And I think in 99.9% of situations, that'll take us really far.
Or get in touch with Zach to get some of those Stop Spiny cloths and you can give them away to your neighbors. There's a question about how hard or soft are the spines exactly? And when we said like they aren't necessarily directly harmful to people, but is that something that like we can detect ourselves, like the spines there?
That's a great question. I don't know the answer to that. They're not dangerous for people. Just to reiterate that, I have a little jar of them on my desk here. Let me grab these. So these are, dead. They're preserved in ethanol, and you can get a license to possess these NR 40 species. But there's about 20 of them in this tiny little vial. So remember, they're quite small. They're not microscopic, but they're like, you know, half an inch long, and they're very narrow. I've never actually like touched the tail spine of a living specimen of spinies, so I'm not sure how tough they are, but they're tough enough to pierce through, you know, the stomach lining of small fish. They're definitely not tough enough that they're gonna like injure you if you step on them or something like that.
Yeah. Okay. I think we got to all the questions. Oh, there's one more. If you, or are they attracted at all to light? Like if you were to shine a light at night, could you possibly detect them that way?
Yeah, I heard such an interesting talk the other day suggesting, so spiny water fleas do this diel migration, which means that they migrate vertically through the water column at day versus night. And there's a really interesting presentation of some preliminary findings basically saying we all go out and do these net tows during the day, but we should probably be doing it at night because they are somewhat more active nocturnally and they tend to be higher in the water column at night. Whether or not they're attracted to light specifically, I don't know, but there is some emerging evidence that's suggesting that nighttime sampling might be the best way to go.
Thank you. Okay, well, we're very close to our time here. So I think I'll wrap this up and say thank you again, Zach, for your presentation. And then I'll remind folks that you will receive a link to the recording of this presentation, and it'll be hosted on the Lake Superior Collaborative YouTube page. So if you want to share it, and I'll also follow up with Zach's contact information. So if you have follow-up questions for him or want to request a different version of this presentation for your group, you can get in touch with him directly. But yeah, thank you again, Zach, and have a good night, everybody.
My pleasure. Thank you, Erin. Thanks for listening, everyone. Be in touch and clean, drain, dry those boats. Good night.